For the next talk for today, we have Ashu Pednekar with us. And you see the topic on the screen. It's going to be QuickGrpc. Ashu is a software architect and a cloud native platform specialist. So before we begin the talk, can we have a big round of applause for him?
Hi, I'm Ashu. I've been doing Python for like 4.5 years now, and last 7-8 months I moved and dragged all my coworkers to doing Rust. And this talk mostly is going to be about gRPC and how it is analogous to REST APIs, right? So that people are not, mind blocked into getting into gRPC. And it also showcases a small tool I made a few years back. Cool. So that's that. There's a link to the talk slides if you want to go later. All right. So yeah, REST APIs are great, right? Why do we need something else? I mean, one thing for sure, front-end integrations, gRPC is still not there because of HTTP 2 not being supported in browsers and all those things, right? So front-end integrations are still there. Documentation is amazing with OpenAPI, right? Once you have an OpenAPI spec defined, you can definitely have good documentation generated. Even SDKs can be generated, right? Another advantage is since it's just HTTP 1.1, most proxies, including Nginx, Envoy, all of those support, Lua scripts, embedding some stuff in the proxy level. So you can do auth and auth for that as well. And lots of mature frameworks like Django, of course, Python, and all languages have REST APIs, proper frameworks, right? And then there's some integrations you have to do with external systems, say financial, for example, right? Where you need some custom payload. Like yesterday's talk talked about match statement, right? Where you have to go through like complicated payloads and, so those kinds of things are perfect for REST APIs, right? All right. So let's talk about the downsides. So serialization, validation, right? So if you get a payload, if you get a JSON payload from an API, and it's up to you whether you want to serialize it or not, validate it or not, right? So that might be a plus for like quick to market, but it's not great in the long run, right? Of course, like for example, if you are in the Pydantic fast API ecosystem, that's better there. But still, it's up to the developer, whether they do validations properly or not, whether they serialize payloads properly or not, right? Then you have to also worry about all these content types, whether you're sending images or JSONs or XMLs, you have to worry about all those things, right? And bidirectional WebSockets do exist, but it's still TCP. It still comes with its own quirks, and not all frameworks, especially in Python, support them natively, like Django especially, right? I mean, there are extension libraries, but it's not like there yet. And I talked about OpenAPI spec in the previous one as an advantage, and it is. But since it's a manual process, right? You're writing OpenAPI, then you're building your APIs. Then you're iterating on the APIs, but the spec remains the same. So it's like very hard to have the OpenAPI adhere to the current APIs and current business logic you've written. So the documentation may not be, self-updating or self-sufficient. So these are some of the downsides of REST APIs. So what does gRPC bring to the picture, right? And where is it used? I mean, as I said, like front-end integrations is usually still not an option for gRPC. And it doesn't have to be, right? I mean, there is a place for everything in tech. So gRPC mainly, there are two benefits. One, the payload that you send, right, is not going to be text. It's not going to be free-form data. So you have to define the data types the way you define structs in C, Rust, the way you define classes, right? Or Pydantic is a good analogy there. We'll come to that in a future slide. So yeah, that's that. Then it's also on HTTP 2. So you definitely have like bidirectional communication supported, client-side streaming, server-side streaming, everything natively. And the best part is since it's a RPC, it's a remote procedure function call, right? The integration is much nicer. Like for example, if you've written a gRPC service in Go and you're calling it from Python and there's some error on the server, you'll get it as an exception directly, right? So you don't have to worry about status code checks and payload validations and all those things. It's native to the language. So that's that. And also, you write a server in one language and you can generate SDKs for almost all the languages that gRPC supports natively. And of course, it supports streaming. So these are some advantages. Mostly, it's used for inter-service communications in microservices, right? Apart from PubSub. PubSub is also used for the same use case, but gRPC is like peer-to-peer between services. So there's that. Okay, so what is protobuf? Protobuf essentially consists of two things. One is the service definition. Let me just put the analogy to Django, right? Let's take Django view sets for an example. So if you have a urls.py and if you have a view set and you have some actions under that view set, right? That's similar to how gRPC expects things to be. So you have a service, and under the service you have RPC methods defined, and each one of these methods will expect a fixed structured message as an input and output, right? So there's a meme there about what do we do about handling payload serialization. Somebody's like, I mean, that's probably me, rewrite in Rust. But protobuf can actually solve a lot of these problems natively. Cool, so let's look at protobuf. Okay, I'm taking an example of CRUD. Usually people don't use gRPC for CRUD applications. It's usually for like doing some computation or some services. But I'm taking CRUD example because that's the most analogous to REST APIs. Cool, so we start a protobuf file like this by writing syntax equal to proto3. Here's the documentation QR code. And okay, so let's take an employee CRUD service. So you have a create list, retrieve, delete services. So you define like this, service employee, and then there are 4 RPCs in that. And each one of them takes an input message and an output message. So if you see, create and list are taking different inputs. List doesn't need anything in an input unless you're filtering, of course. So it takes an empty message as an input, and it returns employees, right? Retrieve and create returns employee. So these are different messages. We'll look at them in detail in the next slide. So you have to define this clearly, right? For example, let's look at the messages here. So let's start with the employee. So we have an ID, name, and some few other details. So this ID would not be there while creating. Usually you don't have the ID, the database, auto increment, big int, whatever. You don't have the ID while creating. So we need another message for employee inp. So that's what we are using here in the create RPC. Right? Similarly, the delete and retrieve need ID. So even though it's like an integer, I can't just say retrieve I64, or I cannot just straight away put a data type there. I need to define a message which is having one field, ID, which is I32. And you might be noticing these numbers equal to 1, 2, 3, 4. So this comes into play where protobuf does serialization with binary. So anyways, so protobuf serializes data as binary data. It doesn't serialize to text. So it doesn't necessarily need the string messages. So for example, if I want to encode name in the employee message, then converting name as a string to binary would be more expensive. So instead we just give numbers to the attributes. And that's what proto-C uses while serializing the data. Cool, so we have this protobuf defined. We have syntax proto3, message empty, employee, employee inp and ID, and employees. So employees here is special. Since list is going to retrieve a list of employees, right? It's like having a pedantic list of pedantic objects, right? So for that we have this repeated keyword. So you can say it's going to return repeated employee, and the field name is employees with ID 1, with number 1. Cool. So once you have the proto file, you are okay to start writing the server in any language of your choice. For that, there's this tool called proto-C, which is again by Google. So it basically takes the language you need as an input, and it generates all these RPC files, PB files, right? So if you go through the documentation here, it'll guide you through doing this process in all languages. But it's very tedious because you have to generate, first of all, you have to write this command, right? You have to have CI/CD around it. You have to generate the PB files. You have to place them in the right place so that you can actually import it in your code. So all those pain points come into play. So that's where QuickGrpc comes in. It's nothing much. It's a tiny dev tool that I made like a few years back. All it does is it makes this process easier. It basically takes your proto-C file, hands it over to, your protobuf file, hands it over to proto-C, generates all of the server code that you need. It generates the starter skeletal test cases also, and it places all the files that proto-C gives us in side packages. So you can just import it like a library, right? And yeah, this is an old tool, and it doesn't really follow the current standards. Like for example, it's not using PyProject Toml. So those are a few things we are supposed, definitely PRs are welcome. Cool. So yeah, let's look at a few demos. Okay. So, all right. So first of all, I'll just speed it up a little. Okay. So this is the proto file that we had. Proto 3, all the messages and the repeated employee. And now I'm going to go ahead and install QuickGrpc. Just a sec. Once that is installed, there's a CLI command you get called create grpc service. It takes in the path to the proto file as an input. And first thing it does, it validates the proto file. So if you have any errors, if you have a missing semicolon, or if you have some ID repeated, all those things it will take care by essentially passing through the output from proto C. So any edge cases that would come, any new feature upgrades that would come to proto C will all pass through. So for example, I changed the ID to, just a sec, I think I missed that part. Yeah, so if I just remove the semicolon, it will give me an error saying that missing semicolon, right? So that's that. So once you have your proto file validated, you can run the same command with a flag -- code. So what that does, it generates it goes through your proto file. It basically parses what all services you've defined, what all RPC methods you have, and it will generate the client and the server code, right? So after this, if we just take a look at the directory tree, So this is the files you have. You have an employee management.py and a test case. So let's just open those files and quickly take a look. So there's a proto file copied over here for reference, which I'll just remove. That's not needed. So in the end, you have this employee management service class, which has the same functions that you defined in the proto file, and it expects all these things. Context is something we can discuss this later. It's not really relevant for this example, but that's it. So this is what QuickGrpc gives you. And apart from this, you also have a test case that is auto-generated, which is nothing but a skeletal thing that tests all those 4 RPCs. So that's what QuickGrpc does. So what we did is we ran the command, we validated a proto file, we generated the server and client code. Cool. Now let's write the logic. So as far as the CRUD is concerned here, I'm not using any database or anything. I'm just straight away using a Python dictionary as a database. So let's just do that. I'll just let this play while we go through. Cool. So I'm going to create a dictionary here called DB, which is going to be like a hash table of the ID to the rest of the proto object. Let me jump to the end of this so that we can just look at the code. Okay, so if you see here, okay, so the employee service, right? Let me just go to the proto file. Yeah, so the employee create RPC, it takes an employee imp and returns employee. So this employee imp is what we can use in our server code. If you see, employee imp is the input that create is getting, and that has all the attributes, name, department, ID, designation, etc. So from that, I'm creating a new employee object, which is different from employee imp because it does not have ID. So once you create that, I'm just adding it to the database dictionary with the length +1 as an ID, right? There's that. So once we have list, let's look at we have create, now let's look at list. So list is slightly interesting. So we have this database where I have essentially ID to proto file directly. So that essentially makes it slightly simpler. But if I had it serialized as JSON, or if I had it saved in the database, I have to convert it back to PV2 objects. So jump to, yeah. So first of all, I need to create an employees object because that's what our list protobuf takes in, right? Quickly, yeah, sorry. Yeah, so list takes in, returns employees, which is a list of employees, a repeated employees proto object. So that's what we're going to do. I created an employee pb2.employees. So if you see this employee management pb2, this import was auto added by QuickGrpc, which is a reference to the code that proto-C has generated. We'll take a look at that under side packages soon. So I'm just iterating through the dictionary and adding it to employee. So res is the employees object, and to that there's a field called employee, right? So that's what I'm going to do. Just a sec. Yeah, so just iterating through the dictionary and extending the employees and returning it. That's all list is doing here. And similarly, we can also do retrieve and delete, which are, just a sec. Yeah, so it's very similar. You have employee ID as an input, and I'm just retrieving that from database. But notice I have to do a .id there because the employee message has an ID field. Employee ID itself is not an integer. So I have to do that and return the same employee object. And in case of delete, I just have to delete that key from the dictionary. And that's it. The server code is done. So after this, yeah, let's move on to the test case once this completes. Just a sec. We take in the employee ID and delete it from the database dictionary like so. That's it. Cool. Now let's update the tests. So we have this server written, we have the 4 methods defined, and we have a test case here. So first thing I'm going to do is combine all of this into a single test case, test CRUD, not even CRUD, I'm not doing updates, so CRD, getting rid of all the other functions here, just for demonstration. And I'll just let it play. So if you see this getStub function, that's imported from QuickGrpc utils. So QuickGrpc utils is including a function called getStub, which will take care of locating the ProtoC generated file under side packages and return the stub object to you. And then you can just call create directly. Create was the function we defined in protobuf, so that's available in the stub object. So you can directly call that. And input to that was employee in, so you have to create that object again here, right? So I'm just creating the object directly manually, and that's it. We have create called. Similarly, let's define all the other things. Jump to the end. Yeah. So if you see, I'm creating one user called Ashu with the designation dev, another user called Jane with DevOps, and then listing, retrieving one of them, deleting, and then listing again. So if you see here, this doesn't look like an integration, right? This doesn't look like any API call to an external service, nothing. It just looks like I have this self.stub object and I directly call list on it. You could definitely abstract API integrations away like this, but you have to do it manually. It's not out there directly. So that's what gRPC brings to the table. Now let's just run it. All right. Cool. So just a sec. 1 second. Yeah. So I had the RPC folder, which includes our protobuf file and all the server and client test cases that were generated. I just had to cd one directory back, export an env called grpc port, and run a command called serve grpc. That's it. Our grpc server starts. And then in another terminal, I'm just going to run the test case. So the test case is under RPC. So yeah, there's a test employee management.py. I just run a unit test on it. It will directly call the gRPC server, and we get our result here. Just a sec. I have to export the port env again and run it. And there you go. So one thing to note, so if there were any errors, right, let's say our server was returning some exception, since it's a Python server and a Python client, the exception would directly come here. So it would not be a status code that I have to validate and some match statement I have to do. I can directly catch the exception from the server in the client. So that's what makes it a remote procedure call. Cool. So let's quickly take a look at what QuickGrpc is doing under the hood. The bulk is, of course, done by the gRPC server and all the things, but QuickGrpc is just bringing the things together. So I'm just hopping over to the virtual environment where this is installed. So I just go there. And if you see, there'll be a folder called grpc assets. So if I go to this folder, it'll have this directory is called employee management greeter. So all the services I've run so far using QuickGrpc in this environment are over here. So this is the code that ProtoC generates for us. It's not really meant to be edited by us, but that's what there is. So all these things, right? So if you see this unary_unary, that's also interesting. Since we are not doing any streaming here, it's unary_unary. We'll look at streaming maybe if we have time later. But it's like gRPC supports 4 things. Unary, as in client is not streaming, server is also not streaming. Client side streaming, where it will be stream unary. Server is streaming, so unary stream, and both of them streaming. So that was that. Now, let me just jump to the test case that we had and go to look at the getStub function. So the getStub function, all right, so what it's doing is this. It basically creates a grpc client for us, and then it imports the pv2 file that Protoc had generated from grpc assets and gives us an object directly. Right, so I'll also quickly open the grpc assets file here so we can see side by side. So the path, if you see, it's grpc assets dot the service that we defined dot the service name underscore pv2 underscore grpc and so on. Right, and not just that, also the serve grpc that we used earlier. Let's take a look at that also. Yeah, so I'm just basically opening the serve grpc server. So this takes care of creating the server for us, and basically you have two options. You can either use thread pool executor for doing multi-threading with threads, or you can use AIO server, which will use Python async IO event loop under the hood, and it will basically detect all the services that you've defined under the folder structure and run it. That's why it's required to be in the same directory as the RPC. And yeah, that's what QuickGrpc does. Yeah, so as I said, most of the gRPC can do. It can do client-side, server-side streaming and bidirectional. If we have time, we can demonstrate that. But yeah, that's it. Any questions? I think we have some 7-8 minutes. Okay, maybe I'll demonstrate the streaming use case. So cool. Let me just zoom this in. All right, so I'll just go to desktop, create a directory called 1 or something. Okay, it's visible, right? Yeah. And I'll create a file called 1.proto. Cool. Syntax equal to proto3. Just zoom this in a little more. Okay. So we define a service called 1. Okay. This is going to have two RPC methods. One where the client is streaming data, one where the server is streaming data. We can do one by one. So let's have first RPC client stream. This name can be anything. Let's say it takes text as a message input and returns text. Now if you note here, I'm taking text as an input and returning text as an input. We have not specified anywhere that I'm going to stream data here. So that's how we need to do. So text is an input which is going to be streamed. So we need to tell protobuf that we are going to be streaming text. Right? So ignore the LSP error. Let me stop my LSP. Yeah. So we specified the text as the data that's going to be streamed. So now what's going to happen is, if I run the create grpc command on this, I need to set the port. So it will validate the grpc file. Looks like I've made some error in the grpc file. Or text is not defined, of course. So let's look at the proto. So this text message that I defined I wrote has to be defined. So let's do that. Sorry. Cool. So I define a message text, which is going to have a string attribute of say MSG, and I give it the ID 1. Right. Okay, that should be okay. And I run this. So it goes through our proto file. It generates the server code, generates the client code, and there we go. Cool. So let me open this directory and take a look at 1.py that's generated. I'll get rid of the reference proto because this is pretty small. I'll get rid of these to-dos as well. Cool. All right. So the input we are going to get is text, right? Now, since we have defined in our proto file that the text is a stream of text, it's going to be an iterator. So that's the nice thing about grpc. Whatever language you use, right, it changes according to that. So if I was doing this in Go, I would get a channel, right? So then I go back to the test here. Cool. So all I have to do is, this is my server code. So I'm just going to go through whatever text is returning me and just print it. So I'm just going to do for t in text, print text dot msg, right? Because that's the property we gave for the string. And as far as the response is concerned, that's also supposed to be text. So let me take the pv2 object from that's imported for us and return a text with msg done. So this is a server code. I'm not printing t, sorry, this should be t. Right? So with just this much code, we have a simple client-side streaming. So let me update the test case also. Just a sec, getting rid of this. Cool. So what I'm going to do is, cool. So here what we need is, first of all, I need a generator function that yields some output. So I'm just going to have a gen function, which is going to say iterate 20 times and yield pb2 text msg equal to I. So we have a function that is iterating 20 times and generating this text object and yielding it constantly. So here all we have to do is self.stub dot, the name was a client stream, right? And check with proto, client stream, yes. So go to my test case and do client strm, if I'm not wrong. Yeah. So client strm, and I just pass the generator, call the generator here. That's it. So now I'm going to go one directory back and do serve grpc. I have to, oh yeah, I have to be in the directory. I have to be in the one directory, just one before the RPC directory. This should be an RPC directory, my bad. Let me just create an RPC directory and move everything in one to RPC and delete this directory. Cool. So now I run serve grpc and the server has started. I create another terminal, go to desktop RPC. Cool. So we have this test directory. I'm just going to touch an init.py under tests, export grpc port and run a unit test. -m unit test one. Oh, there's some typo in the test case. All right. So this is supposed to be in the test case. Oh, sorry, this is too small. Yeah, this is supposed to be client stream. Where is that happening? Yeah, this is wrong. L is missing. Okay. Or is the one in the proto wrong? Oh, okay. Fine, I'll put CIENT here. Test case, CIENT. And run the test case. So I went through and all the 20 messages came to the server. Similarly, if I wanted to like stream from server to client, I just have the generator on the server side and iterator on the client side. So that's how we can stream data on gRPC with QuickGrpc. Yeah, that's about it. Any questions? I think we have some 1.5 minutes. That's it. Yeah. Any questions?
Hello. I have one question.
There is a question.
Sure.
Let's say we have two services.
Okay.
One is purely gRPC based and another one is REST API based.
Okay.
So, is it possible to interact these services to interact without creating a third service to support that?
Okay, so that's what, right? So if you have, let's say, a service for authentication, which is gRPC, and you have your Django service for some business logic, right? So if you want to call this gRPC service from Django, that is fine. You just add the
Yeah.
client to your code and that's it. But what do you mean? Is the Django service also wants
Yeah.
to have a gRPC endpoint? No, then you have to run a separate process. It can run in the same process, like you can, same Docker container, you can have an entry point and run two processes. But yeah, it has to be, because like the concurrency, like for example, if this was Rust or Go, you could just spawn a Go routine or a Tokyo thread with a gRPC process. We can still do it in Django, but it's a little painful. So separate process is better anyways to manage.
Yeah.
for you.
Thank you.
Thank you.
Hi, Ashu. Sandeep here.
Hi, Sandeep.
Yeah. So my question is like in traditional API, which is REST API, if you want to encrypt the data from the client to server
Right.
over the internet, we will use like a HTTPS.
Correct.
So how it is like a handle the same case in this gRPC?
Yeah. So gRPC is still HTTP, right? It's not like a TCP server. Like for example, if I had written a TCP server, we have to worry about TLS and all those things. But since gRPC is also based on HTTP, let me just quickly. Yeah, since it's also HTTP, just that it's HTTP2, the same encryption methods, TLS can work. Even proxy level, I think nowadays Nginx supports authentication checks, and even TLS encryption is natively supported. In fact, HTTP2 mandates TLS, like you need to have, that's HTTP3, my bad. But yeah, the same TLS can work for gRPC as well.
Thank you.
Thank you so much, Ashu, for the session. Folks, if you have more questions, you can catch Ashu around offline, and he'll be around to take your